We are going to be solving radical equations. They can be tricky little buggers, so you have to be very careful. Very careful. For instance, at least one of your radicals, and here there is only one, has to be isolated. At least one of them has to be all by itself, and it is. So we're doing fine. So here we're going to talk about what is your strategy. Well, in the end, you want to be able to say x equals 1. I don't know that. But you need to be able to say x equals something. But x is locked up underneath a square root radical. We have to free it from its prison. And that's what we're going to do. We're going to blow up the jail. A little extreme, perhaps. So we're going to explode the radical by squaring that side, and for sure, whatever we do to one side, we have to do to the other. So I have to square the other side as well. Okay, now the great thing about a square root radical that has an invisible index 2 and squaring it is that these are inverse operations, and so they undo each other, rather like matter and antimatter. So they cancel each other. Kaboom! We have blown apart the jail and the prisoners are now free, which might be good or bad. But x is free and that's what we need. So when I square this square root, I get what's underneath the square root, which is called the radicand. So 4x minus 17 is going to equal 1 squared, and 1 squared is 1 times 1, which is 1. I need more practice trying to do that. Okay, now we're just going to solve the equation. I am going to add 17 to both sides of the equation. So I get 4x equals 18, and I divide by 4, and I divide by 4. My answer is not 18 over 4, because when you have a fraction answer, it has to be reduced. So let's see, that's going to be 9 over 2. Cool beans. The nasty thing about these kinds of equations is that you can do everything completely correctly, get the right answer, and the answer still won't work. So you have to be careful to always check your answers, and that's what I'm going to do. Go back to the original equation, 4x minus 17 equals 1. And we're going to see if that's true. If x really does equal 9 over 2, I can put 9 over 2 in there. So I'll have 4 over 1 times 9 over 2 minus 17. Now this is just so you can do it by hand easily. 2 goes into 4 2 times. So we'll have 2 times 9 is 18. Still under the square root sign we'll have 18 minus 17, which is going to be the square root of 1, which is 1. So this happens to be true, which is a good thing. So I write 9 over 2 in the answer box, completely confident I have the correct answer because I checked the answer. I promise you that you are going to get untrue answers. This was just a lucky break, a lucky first time. Okay. So notice what we did. We isolated the radical, it was already isolated. We squared both sides of the equation, which liberated the x. And it liberated everything else that was with it, all the cellmates as well. So we had 4x minus 17 and 1 squared is 1. And then we just solved the equation, and then we crossed our fingers and checked the answer, and the answer proved that you have the same answer on each side of the equation, which is true, because 1 really does equal 1, and that means that 9 over 2 is the answer we want, the solution. And now we move, yes.
I'm just wondering how you got the 18, whereas like when you were checking the answer and it says 18 minus 17.
Okay, here. 4 times 9 over 2 is 4 over 1 times 9 over 2. And 2 goes into 2 1 times, 2 goes into 4 2 times.
Oh, I thought it was a 24 over 1. Okay, that makes sense. Sorry.
Great, thank you. Thank you. I'll try to make it more clear, like mark through it a little better. All right, now, here we have another one. The square root of 5x is not by itself. There's a 2 added onto it, so we have to subtract that 2 off the left-hand side, so that our square root of 5x is isolated, and 9 minus 2 is 7. Now we have a radical expression equals a number. So we're going to square both sides in order to blow up the jail. Kaboom, and there you go. We're going to have 5x equals 49 and divide by 5 and divide by 5. And there's no way for me to reduce that, pretty sure. So x equals 49 over 5. Do we really have to check the answer? Yes. The square root of 5 times x plus 2 equals 9. So the square root of 5 times 49 over 5 plus 2 equals 9. Now, the easiest way to do this is to take 5 and write it as 5 over 1, so that you're multiplying a fraction times a fraction. And then you notice that this 5 and this 5 cancel each other, and you're going to be left with the square root of 49 plus 2 equals 9. Now, is that true? The square root of 49 is 7. 7 plus 2 is 9. 7 plus 2 is 9. 9 equals 9 is a true statement. 9 equals 9. So this is true, which means this is true. So X equals 49 over 5. And we're done with that. Now at this point, it is probably seeming pretty stupid to you that we went to all the trouble to check the answer. But when we get to the next equation, you're going to find out that it was a really good idea. Here we have the square root of x plus 5 equals -9. I have to square both sides so I can get x out of jail. And the cellmate plus 5. There. So what will that do for us? This, the square and the square root cancel each other out, and we're left with x plus 5. And over here we're going to have -9 times -9, which is positive 81. And then we subtract 5 and subtract 5. So x equals 76. And now I'm going to go back to the original equation. And I'm going to put 76 in for x. And that'll be the square root of 81 equals -9. But this is a symbol for the positive square root of 81. So the positive square root of 81 is 9. And so we're saying that 9 equals the opposite of 9, which is -9. That's not true. They're two entirely different numbers. So this is false. Which means this is false. And our only solution is no solution. Sad face. I always felt like I go to all that trouble and then I get a no solution. It's kind of a crummy feeling. Like you wasted your time, but you didn't, and this saved you over here. Right? If it hadn't been for that, you would have gotten a wrong answer. And you'd rather not have that happen. So always check your answer. We're going to be moving into some problems where one answer is right and one answer is wrong. Oh, incidentally, the wrong answers, like 76, we did everything right. Did everything right, and we got what should have been the right answer, but it doesn't check. This has a special name. This is called an extraneous solution. Notice the word extra in front. That's what extraneous means. It's an extra answer that you don't need, and you get it because you squared both sides of the equation. Sometimes, but not all the time, when you square both sides of the equation, you get an extraneous solution. But the problem is you don't know when it's going to happen. And that's why you have to always check your answers with this kind of problem. Discussion. Okay, let us move on. Now we're going to get some real problems. I mean, real math problems. Real radical equations. They're coming to get us. Wrong people. They're the heroes. I live 4 blocks from a fire station. I know every time they leave the station. Every time. Okay, our radical is isolated. So I'm going to square the left side of the equation and square the right side of the equation. Over here on the left, I'm going to have x minus 9 times x minus 9. And over here, the square cancels the square root, and I have x minus 3. And now I'm going to solve this equation. Okay, so we're going to have x squared minus 9x minus 9x plus 81 equals x minus 3. I always found it easier to combine my like terms before I start bringing stuff over. So this is going to be x squared minus 18x plus 81 equals x minus 3. Now this is a quadratic equation. The highest power is 2. So what I need to do is pull everything over to the side where the x squared is positive, and it is over here. So I'll pull these over here, and that way I can set this equation equal to 0, and we can go about solving this quadratic equation any way we can. So I'll subtract x. I'll subtract x, and that's a 1x. And I will add 3 because x minus x is 0. Negative 3 plus 3 is 0, and we know that 0 plus 0 is 0. So bring down your x squared. You subtract 18x, then you subtract another x, so you've subtracted 19x plus 81. And we are now going to see if we can factor that, and if we can't factor it, we can use the quadratic formula. So let's see, 81. Well, let's break it down like this. 81 is 9 times 9. Which is 3 times 3, and 3 times 3. So 81 equals 3 times 27. That's true. All right, so now 81 equals 1 times 81. And 2, no, but 3 times 27. 4, no. 5, no.
I have a question.
Yes.
Are you supposed to add the 3 to the 81?
Yes, and I didn't do it. I forgot. Thank
All
you. You have rescued us. My hero. Maybe it'll be easier to factor now. Okay. Yes, of course, you silly person. Me. Well, that'll make it 84. Now, 84 could be easier. At least 2 goes into it. Or we could just give up and use the calculator. All right, we're going to use our wonderful cheating method. Go to y equals. We've got 84 there. 84 divided by x, and then come down to y2, and we'll have x plus 84 divided by x. Yes. And then I click on second graph. And what am I looking for? I'm looking for negative 19. Well, if this is factorable, we will find a negative 19 over here in y2. Now, the quickest way to encounter the negative numbers in y2 is to move up. Negative 19. We'll use negative 7 and negative 12. So here, let's do this the legal way and pretend we always knew it. And what was that? Negative 7 times negative 12. See, we always knew it. Negative 7 plus negative 12 is negative 19. All right, cool beans. Boom, 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 boom equals 0. So x and minus 7 and minus 12. And I'm going to turn off my phone. I forgot again, but let's see. Maybe just putting it on airplane mode would be a good idea. Airplane mode, yes! Okay. Now, x minus 7 equals 0 and x minus 12 equals 0. Add 7 to both sides, you get x equals 7. And add 12 to both sides and you get x equals 12. And it sounds like such a wonderful idea to say that x equals 7, 12. But it might not be true. So we go back and we check. With the original equation, x minus 9 equals the square root of x minus 3, and we'll check the other answer as well. X minus 9 equals the square root of x minus 3, and here we're going to check x equals 7 And here we're going to check x equals 12. Okay. So 7 minus 9 equals the square root of 7 minus 3. So negative 2 equals the square root of 4. Negative 2 equals positive 2. Not true. False. As a result, we need to throw out x equals 7. And you cannot assume that 12 will work, unfortunately. So we have to check that one too. All right, 12 minus 9 is 3. 12 minus 3 is 9, so this is the square root of 9. And the square root of 9 is 3, and it really is true that 3 does equal 3. Which means that x equals 12 is our only solution. So x equals 12 is the solution. And x equals 7 is extraneous. Questions, discussion, comments, concerns. Okay, let's do it again. Here we have two radicals. No worries, we're going to do exactly what we did before. Notice that this radical is all by itself on the left side of the equal sign, and this radical is all by itself on the right side of the equal sign. So they're isolated. One of them is isolated anyway. So we will square both sides. And that will give us 5y plus 1 equals 4y plus 11. Not even quadratic, which is pretty good. Subtract 4y, subtract 4y. Which will leave you with 1y, right? 5 minus 4 is 1, so y plus 1 equals 4y minus 4y is 0, so we'll have an 11 left over here. And I subtract 1 from both sides. 1 minus 1 is 0, so y equals 11 minus 1, which is 10. And now we check 10. 5 times 10 plus 1 equals, well, the square root of 5 times 10 plus 1 equals the square root of 4 times 10 plus 11. Let's see. The square root of 50 plus 1 is 51 equals the square root of 40 plus 11 equals the square root of 51. Those numbers are exactly the same. Therefore, this is a true statement. which means y equals 10 is our answer. And you put 10 in the answer box and mosey right along. How's that? Notice, even if you end up with something that surprises you, you just stick to the rules. And you bully on through. Please feel free to blurt out. I think that's great. Now, look at this. We have two radicals on the same side of the equation. The first thing I have to do is move one of them, and it doesn't matter which one. So probably I'll just subtract the square root of y from both sides of the equation. The square root of y minus the square root of y is 0. So I will have the square root of y minus 9 equals 9 minus the square root of y. Now I have one radical all by itself. So now the steps say that I square the left side of the equal sign and I square the right side of the equal sign. Which means over here, that liberates the radicand. Over here, I'm going to be doing something we talked about yesterday. Multiplying radical expressions. So, just for the sake of tradition, I'm going to draw my little kind of arrows. And even though that looks exceptionally ugly, we're just going to follow through. We'll have y minus 9 on the left, waiting for us to get done. Here we go. Take 9 times 9 is 81. 9 times minus the square root of y is minus 9 times the square root of y. Now minus the square root of y times 9 is also minus 9 times the square root of y. And then we have a minus the square root of y times a minus the square root of y. Since minus times minus is plus, or negative times negative is positive, we're going to have a plus sign. And the square root of y times the square root of y is the square root of y squared. So see if you go slowly and methodically, you get there. And I need to remind myself of that, not to speed up, but to slow down. So here we go. Y minus 9 equals 81. This, I subtract 9 square roots of y and then another 9 square roots of y. That means I've subtracted 18 square roots of y. And over here, we have the same situation where this square blows up that square root, leaving me with the radicand, now free. And now, I have a radical term, and the rest are not radical terms. This is like the halfway point. Okay? Because now, the rules say we have to isolate the radical, or the radical term, which means I have to subtract 81 and I have to subtract y. There. Okay, so over here, 81 minus 81 is 0. Y minus y is 0, so we're left with negative 18 times the square root of y. Over here, y minus y is 0, so I have negative 9 minus 81. That's negative y plus negative 81. That's going to be negative 90. So negative 90 equals negative 18 divided up times the square root of y. Now, before I go any further, I'm going to call, who are you going to call? Not Saul, but my calculator. And I'm going to say, calculator, do me a favor. Tell me if negative 18 can go evenly into negative 90. I honestly have no idea. And I would say probably not. Whoop. Negative 90 divided by negative 18. It does! Ooh! Doesn't always, well, that does always. Sometimes you're not this lucky, so don't assume you will be. But notice what we can do. Instead of just having to square both sides, which we could have done and we would have gotten monstrous numbers, we can divide out the negative 18. Like that. So the negatives cancel, the 18s cancel, and you're left with the square root of y. Negative 90 divided by negative 18 according, no, that's my email, according to my calculator is 5. You'll be glad to know if you saw my email that the NWAC bookstore misses me. I am so special. Okay, enough of that. I bet you've got an email like that too. We are all special. I'm going to square both sides of the equation now. I have to because I have a square root. 5 squared is 25. And this second power blows away the square root because they're inverse operations. And I'm left with a y. Y equals 25, I'm done. No, not necessarily. We have to check and make sure. So let's check over here. I would love it if it were true. The square root of 25 minus 9 plus the square root of 25 equals 9. Well, 25 minus 9 is 16, so the square root of 16 plus the square root of 25 equals 9. The square root of 16 is 4. Notice I don't use the radical. Once I take the square root, I mean the square root of 16 is 4. Because 4 times 4 equals 16. I don't have to put a radical over the 4. Some people do that. And then it forces them to get the wrong answer, and it's very messy, so don't do it. The square root of 25 is 5. And it looks to me like 4 plus 5 is 9, and 9 equals 9, and this is true, which means that x really does equal 25. So x equals 25. And now we know for sure. So notice you had to isolate the radical, then square both sides. And when you got down to what I call the halfway point, because I think of it that way, and a lot of the time it is, you have to again isolate the radical, move everything else over, and then square both sides. It's not often that easy. But you keep following the same rules until all of the radicals are gone from your equation. And notice how you carefully square 9 minus the square root of y. It means parentheses 9 minus the square root of y, parentheses 9 minus the square root of y. There are no easy way outs, and well, sometimes there are, but not here. Okay. Here we have two radicals. 3 plus the square root of z minus 13 equals the square root of z plus 2. Now this square root is isolated, it's all by itself on either side, right? All that matters is that one of your radicals is all by itself on one side of the equal sign, and it is. So we are now ready to square both sides because otherwise z is trapped in prisons. So we can easily blow up this cell and liberate z. along with the cellmate. That was my story. Stories help. They help you memorize. They're wonderful tools. On the other hand, if I want to keep this story going, it looks like somebody could get hurt. I mean, what's a good story? It's attached to another building? I don't know. Anyway, this is what I have to do when there are two terms over here. C plus the square root, 3 plus the square root of z minus 13, in parentheses, times 3 plus the square root of z minus 13, in sort of parentheses, ugly parentheses. You do what you have to do. Okay, so now we're going to have to use our little arrow dealy. 3 times 3 times the square root of z minus 13, the square root of z minus 13 times 3, the square root of z minus 13 times the square root of z minus 13, and they're all positive, so I don't have to worry about sign errors, which is kind of nice. Okay, 3 times 3 is 9. 3 times plus the square root of z minus 13 is going to be plus 3 times the square root of z minus 13. And then plus the square root of z minus 13 times 3 will be plus 3 times the square root of z minus 13. Whenever you square two terms in parentheses, you'll always get this doubling effect in the middle. And then adding plus z minus 13 times plus z minus 13 is going to be plus the square root of z minus 13, but squared. That's the square root of z minus 13 times the square root of z minus 13. So this is what you have on the left side of the equation, and over on the right side of the equation, you have z plus 2. So now this looks awful, but you persevere. That'll be a 9. Plus, I have 3 square roots plus 3 square roots, which means I have 6 square roots. And then plus, here we have again that case where you've got one square root here being squared, so the square will blow up the square root, leaving you with z minus 13. And over here on the right, we still have z plus 2 waiting to play, but not yet. Because notice that I have a 9 minus 13. What would that be? -4, right? So I will have 6 times the square root of z minus 13 plus z minus 4. Yes. Equals z plus 2. Kind of pause, take a breath. Okay. Now I have to isolate the radical again and start all over, sort of. Minus z minus c plus 4 plus 4. Z minus z is 0. Negative 4 plus 4 is 0 over on the left. Over on the right, z minus z is 0, and 2 plus 4 is 6. This is unfair. They're making stuff too easy for you. Well, all right, I'm going to take this now and write it down there, because that's all I have left on the left side. 6 times the square root of z minus 13. And because 6 is multiplied by the square root, I can divide it out. I can divide it out when I know it'll go evenly into the number over there. Otherwise, I'm kind of making life more complicated for myself. So we will have the square root of z minus 13 equals 1. And once again, I will square both sides of the equation. On the left, the square and the square root cancel each other out, leaving me with z minus 13. On the right, I have 1 times 1, which is 1. Now I'll solve for z by adding 13 and by adding 13. So that I come away with z equals 14. But I do have to check my answer. So let me draw a line. Check. At least I only have one answer to check. Check, we're checking z equals 14. Okay, so we're going to have 3 plus the square root of 14 minus 13 equals the square root of 14 plus 2. Now, this is going to work. I can tell because 14 minus 13 is 1. We're going to have the square root of 1. 3 plus the square root of 1 equals the square root of 16. 3 plus the square root of 1 is 1 equals the square root of 16, which is 4. 3 plus 1 is 4, so we have 4 equals 4, and that's true. Could we have gotten a false? Sure. If we had come up with the answer z equals 15, we would have gotten a false, which would have meant we had to choose the answer no solution, because there would be no solution. You're just lucking out, and I happen to choose problems that let you luck out. Word problems. You saw these yesterday in that long list of problems. Here they are. And now we're going to take them on because we are tough. And I included the answer. Notice we're going to round to the nearest whole number. All right, let's read this. At a height of 8 meters above the ground, you can see v kilometers to the horizon Let's draw a little picture. Suppose you're sightseeing in, I don't know, how about the Cascades? Hoping there's not going to be a giant earthquake and a tsunami. So you're on this stand. Here you are. And let's see, can I make a face that's odd? No, you just fell off. No, that's terrible. Amazon, go away, please. Oh, yeah, there you are. And, all right, so you're looking at some beautiful sight out here. Now, what this says is if you are h meters above the ground, let's say this is the horizon for you, and you're in the Cascades according to our story. So they're all volcanoes, you know, they really are. If you are h meters high above the ground, that would have to be really high above the ground, but yeah, okay. You can see V kilometers to the horizon. Now these numbers are related by, I have to work on this story and the artwork, obviously. These numbers are related by this formula. Thank goodness they gave us a formula. V, the distance in kilometers to the horizon, equals 3.5 times the square root of your height above the ground. How far can you see to the horizon? What is V? Through an airplane. I should have read the whole thing. Okay. How far can you see to the horizon through an airplane window at height or altitude 13,000 meters? We do have to change our story. You are suddenly 13,000 meters above the ground. OMG. And you can see this many kilometers. So, how far can you see to the horizon? We know what the answer is, so let's not bother to do the problem. No. At an altitude of 13,000. Okay, fine. All right, let's do this. Get our friendly calculator. 3.5 times the square root, second x squared, of 13, I just did a 16. 13, 0, 0, 0. Okay, I'm going to hit enter. And that's our answer. Let me go ahead and copy it here. There. here we've got our decimal, and they, I keep forgetting that happens, obviously. And they want us to round to the nearest whole number as needed. Well, here's the nearest whole number. And if that were a number 5, 6, 7, 8, 9, or 9, that would round the 9 up to a 10, which would round this whole thing up to 400. But it's only a little old 0. So that 0 is not going to cause the 9 to round up. Therefore, our answer is going to be 399. You could be on a magic carpet. Duh, problem solved. Okay, magic carpet, let's make a note. High-flying magic carpet. There is a way around every problem somehow. Problem is finding it. Okay, one more. Questions about this? Okay. Now, we have another one that hits closer to home. This formula can be used to approximate your speed, R, in miles per hour, of a car that has left skid marks L feet long. How far will a car skid at 80 miles per hour? Okay, so let's write this down. We have R. R is R because it is the rate of speed. So let's actually write that down. Rate of speed. And this is in miles per hour. And that equals 2 times the square root of 5 times L, where L is the length in feet of your skid marks. Bringing back bad personal memories when I almost plowed into the back of a car. But I didn't. My brakes worked, but I guarantee I left a skid mark. In feet. Okay. So now they're telling us how far will a car skid? So they're looking for L. What is L? When you're traveling at 80 miles an hour down a local neighborhood street that has posted 30 miles per hour. Yeah. Okay, so you're traveling at 80 miles an hour where you should not be traveling if you're going to go 80 miles an hour. All right, now we have 2 on the outside of the square root. Visiting hours. If we keep up the story with that being a prison cell, that's your mother visiting you and your roommate, cellmate. Okay, well, we can eliminate your mother very easily. Time to go. So she has to leave. Since she is multiplied, she's glued onto the cell and refuses to leave her baby, and they're dragging her away. Okay, So we have to actually divide her out. Oh dear. So 40 equals the square root of 5L. We have now isolated our radical. We're going to square both sides. Boom, your mom snuck back and she blew up your cell. So here we're going to have 40 squared, and that is 1600. 40 times 40. Meanwhile, over here, you and your cellmate are free. Well, now we're going to divide out your cellmate, aren't we? So that we can solve for L. Help! Help! And now we're back to this being the length of your skid mark. So your lawyers come to talk to you. All right, do you know how long your skid mark was? No. Well, let me tell you. Well, Barb, see, this is my big problem. Remembering to turn it on. If I were using a real calculator, I could see that it's not on, right? I'd have to look at it. But I just make assumptions. 1600, you could not have been going that fast, divided by 5. 320 miles an hour, you were not. Oh, you were. They're gonna put you under the jail. Must have been a really good party you were coming from. That's how you do this. And what I did is, I have no idea if I entertained you with my little stories, but I certainly entertained me. And so I made solving a math problem more fun for me, which is another reason why you should try it. Okay, I'm done. Questions about anything we talked about today?